Third time lucky. In this video we're going to look at factorising by completing the square. Firstly, what I want to do is go through just a little bit of revision on a few things that we've looked at. So in this quadratic here, we know that to factorise this quadratic, we're going to end up with two things in brackets, and we need to look at the last number here, and we need to find the factors of 12, and then what two numbers multiply to be 12 and add to be 7. So obviously 1 and 12, 2 and 6, and 3 and 4. Doesn't take too much idea to see that 3 and 4 multiply to be 12 and add together to make 7. So in our brackets, x squared, so our first polynomial is x, and our numbers are going to be 3 and 4. If you can't remember how to do this, you need to look at some previous videos on factorising quadratics, and because these are both positive, these will also be both positive. Now this next one looks pretty much similar. We've got 9, so we're looking for the factors of 9, which are obviously going to be 1 and 9 or 3 and 3. Now obviously it's 3 and 3 because 3 and 3 add up to be 6. So that gives us our two sets of brackets, our x squared, x in both brackets, 3's in both brackets, and pluses in both brackets. Now, because both of these are the same, these are squared. So it's x plus 3, and it can be written like that. Nothing new here. Now, the third example that I've got here, when you look at that, you go, oh, not the same, but it is the same. This one, if you remember, is the difference of two squares. So we find the square root of this and the square root of this. So if we have the square root of x squared plus the square root of 36 and the square root of x squared minus the square root of 36. When we have plus and a minus, if we have the same terms here and here, the middle two terms cancel out. So when we find the square root, we know that the square root of x squared is x, and the square root of 36 is 6, and the same on this. Okay, so for some of you, this might be a step that you haven't really seen before, but you can see that the square root of this number is x, the square root of this number is 6, this is plus, and this is minus, which causes those middle two terms to cancel out. Okay, nothing new there. If we have a look at x squared plus 8x minus 3, looks the same, all cool. Alright, so what are the factors of minus 3? 1 and 3. 3 and 1, 1 and 3. In no way, shape or form can we add or subtract those to get 8. So this is a bit of a problem. So what we're going to do is create a square. So we'll take x squared plus 8x and we'll use that part of the equation to create a square like this one here, and then we'll separate that from the second part of the equation, which is the minus 3, and we'll balance the equation up using this side. So what does that mean? X squared plus 8x. If we would complete this, what number do we have to add to make a square? So if we divide this by 2, two numbers to add to the 4 and 4. 4 plus 4 is 8. So when we multiply those two numbers, we get 16. So what we're going to do is add 16 to this side, or to this part of the equation. Whatever you do, we cannot change the value of this equation. So what we're going to do is, because we added 16 here, we're going to also subtract 16. It's the same equation, but we're going to subtract 16, and then we've got our minus 3 from this part of the equation. So the minus 3 is there. So what we've done is we've added this bit here in the middle of the equation, plus 16 minus 16. Because that equals 0, it doesn't change the net worth of the equation. So if we find the square of this, we know that that's going to be x plus 4, x plus 4, and when we add this part up, minus 16 minus 3 is minus 19. So we just find the square of this side equals x plus 4 squared minus 19. So now we've factorised this by finding the difference of the square. The net value of the equation is still the same. Okay, so for most of you, we probably need to just stop at this point here. But if we're trying to solve the equation to find what x is, we need to go a little bit further, and we need to actually now look at this equation and say, well, this is a difference of two squares. We can use this to factorise this. So we can say that, like I did here, the square root of this term plus the square root of this term, so if I write that down, I'll write it a bit bigger, the square root of x plus 4 squared plus the square root of 19, so that's one set of brackets, and then in the other set of brackets is the square root of x plus 4 squared minus the square root of 19. So see how I've taken the square root of this and the square root of this to create a difference of two squares. So I've done that there. So if I write that out without the square roots, the square root of x plus 4 squared is just x plus 4. And we'll leave the square root of 19 in third form, and then on the other side x plus 4 minus the square root of 19. We can expand that out, or you can get rid of the brackets inside. So the answer to this is x plus 4 plus the square root of 19 times x plus 4 minus the square root of 19. So when we're trying to solve to find what x is, we can use this form here. Alright, we'll just leave that at that point.